The last example that we have for analyzing limits analytically is one with radicals in it. So limit as x approaches 1 of the function square root of x minus 1. The minus 1 is not underneath the square root, all over x minus 1. So we see here on top that we have a radical. Okay, when we try to do direct substitution by plugging 1 in, we get 0 over 0, or in other words, undefined. So before we make the conclusion that no limit exists or that it does not exist, we would want to see if there's anything we can do algebraically. With radicals, you're going to do something called rationalize by multiplying by the conjugate. So we're used to getting rid of the radical at the bottom by multiplying by the conjugate, but sometimes with limits, what we're going to try to do is multiply by the conjugate, whether that is to the numerator or the denominator, to adjust the expression and then try direct substitution again. So here I see that the radical expression is on top. So what I'll do is multiply by the conjugate. The conjugate will have the two terms, square root of x and 1. And instead of a negative sign or a subtraction sign in between those two expressions, we make it the opposite. So plus 1 because the original had minus 1. In order for us not to change the overall value of the original function, we're going to multiply top and bottom by that same conjugate value. And now what we do is we distribute top and bottom. So let's say we do the top first. Remember that when we multiply by the conjugate, the nice thing that happens is that the middle terms cancel out. So we end up with radical x times radical x is just x. Negative 1 times positive 1 is minus 1. Then we have our limit expression at the front. And then at the bottom, well, I'm going to, for now, just leave it, noticing that on top I have x minus 1. So what we have as a result is a factor on top and bottom that we can cancel. And that's going to leave us with a number 1 on top as the numerator. So limit as x approaches 1 of the original is the same as the limit as x approaches 1 of the reduced fraction. So 1 over square root of x plus 1. At this point, we try direct substitution again, and voila, we do get a value that's does not exist. So when we plug it in, we get 1/2.